Hello everyone. First, let's determine what problem we want to identify. There are times when the load on the database CPU increases sharply, but there are no long-running queries. Most often, this is a looping problem when the same request crashes the database. The task is to quickly identify this request without waiting for example, aware reports. One solution is to analyze $SQLAREA. The prefix G means that this is in the context of all instances. $SQLAREA is a system view and is an aggregation of $SQL. I will give an example of what is contained in these views. The same query, due to different execution plans, can have several records in $SQL. We perform the analysis as follows. First, save the current state of $SQLAREA in memory. Second, let's pause using dbmslog sleep, for example, for 10 seconds. 3. Save the new state of $SQLAREA in memory. And 4. Let's find the delta of the numerical values, that is how much they changed by 10 seconds. We will do the entire analysis within one SQL query. In real condition, the process would look like this. First, an alert comes from the DBA that the load on the database has increased sharply. Second, we ask the DBA to send the result of the query, in which the analysis of $SQLAREA. To execute an SQL query, no additional actions are required. The SQL query doesn't create or update anything inside the database. This is important, since a real database doesn't always have the ability and rights to create an additional tables, packages, and procedures. For testing, we will create a user under which we will run queries. Case 1. First, let's launch several processes in which the same request will be executed in an endless loop. Second, let's check where our request reveals this problematic situation. We will analyze an abnormally large number of executions. We have launched 3 processes that endlessly request the same SQL query. Next, we run an SQL query that analyzes $SQLAREA. The time interval between 2 snapshots is 10 seconds. The script worked. To conveniently display the results, let's view it through an HTML browser. We see that all 3 of our looped queries are included in top by executions. Each of the requests within 10 seconds was executed more than 300,000 times. Through $SQLAREA, we can identify not only queries that are executed very often. Therefore, let's make the SQL query more universal. In it, you can configure: first, delay time between two snapshots. 2. Don't show records where delta is less than threshold value to avoid littering the output with irrelevant information. 3. For each of the statistics, display only top values. And 4. For default, all statistics will be analyzed, but you can specify only those that are interested. Let's run the previous test, but look at the top of all statistics. It's expected that our looped queries were included in many tops, including in terms of time. But for SQL queries, top by execution is enough to detect looping. Next, let's check the case when PL SQL code gets caught in an infinite loop. Let's launch 3 processes in which we will loop the PL SQL code. Next, we run an SQL query that analyzes $SQLAREA. The time interval between two snapshots is 10 seconds. The script worked. To conveniently display the results, let's view it through an HTML browser. In the case of PL SQL code, the PL SQL exec time statistics most clearly indicate the problem. We see that PL SQL exec time approximately 10 seconds, and the time between snapshots was also 10 seconds. In conclusion, I would like to note that $SQLAREA is a very useful view to quickly identifying problem situations, and such SQL with stops should always be at hand. That's all. Thanks for your attention. See you again. Bye everyone.